Hey there, guys. Today we're going to look at point slope form yet again, but we're going to look more at the graphing side of things. So, all right, here we go. So, again, back to point slope form. All right, so here's our first example. Remember, when we've graphed in the past, we needed a slope. And in this case, we're actually going to need a coordinate. So we're going to need an x and a y value. Remember, our point slope form is this. So the slope we can grab immediately. The slope is 2/3, while the x and y are in the equation, but remember there's the subtraction, so that means when we take them out, we need the opposite. So for the x, it's a -3. The opposite of that would be a +3. So for the y, it says +2, so the opposite of that would be a -2. So in order to begin this, we are going to graph that point, which is 3, -2, right here. And then we're going to use the slope to help us graph the rest. Remember, slope is rise over run. So my rise is 2, my run is 3, so there's that point. And then we're going to go the opposite direction to get enough points on there to have a line to graph. Now the cool thing is we can actually take that point slope form and convert it to slope intercept to make sure that we did this correctly. So we have y plus 2 equals 2/3 times x minus 3. So y equals hello, that was a mistake. Y plus 2 equals 2/3 x minus 2. So now I am going to subtract 2 on both sides. So I have y equals 2/3 x minus 4. So essentially this is the only thing that's really going to help us. And 1, 2, 3, 4. So that y-intercept is at 0, -4, which is what we just discovered. -3? Yes. Back here, I can see this is 4, 1, 2, 3, 4, 5, 6. So my graph also crosses here at 6 at the x-axis. So Desmos is very handy in that sense. Another option is to actually use Desmos to graph. So we can do y plus 2 equals, and in parentheses 2/3, close those parentheses off, whoops, times x minus 3, and then hit enter. Of course, it depends on the setup of the graph, but you can see the y-intercept is at -4. The slope is about average. My graph also crosses the x-axis at 6. So when all right, so we also need to grab a slope and a point from this equation. Remember again, the slope is here, so that would be 3/4. Our point, xy, comes from the equation, and when we take it out of the equation, it's opposite. So, for example, the x is a +1. When we take that out, it's actually a -1. For the y is a -1 in the equation. When we take that out, it's a +1. So when we graph this, we go -1, +1. So we're looking at this point here. And then we're going to use our slope of 3/4. So a rise of 3, 1, 2, 3, a run of 4, 1, 2, 3, 4. So we're here. And we'll go the other direction as well, just to have more than 2 points. Hope I did that. Nope, I think I didn't go far enough. 1, 2, 3, 1, 2, 3, 4. So here it is. Connect it. Of course, I'm not good at connecting, but there you go. So there's our equation. Now, I want to talk about the y-intercept being like kind of a weird place. And I don't know for sure what it is. So what I want to do is change this equation to that point slope form or slope intercept form so that we can see what that looks like. So y minus 1 equals 3/4 times x plus 1. So y equals 3/4 x, and then 3/4 plus 1 is 1 3/4. I'm going to change it to improper, so it would be 4, 7/4. So in this case, would you say that this is about 1 3/4 or 7/4? I would say, yeah. So it's about, because of course my line is not drawn to scale. So then this would suffice and match this equation. Of course, you can also graph in DES if you choose to, so don't forget to use that as a resource. Now here, we're actually going to write the equation in point slope form, so y minus y1 equals m times x minus x1. So it says use the right-hand point, so the right-hand point would be this one here. So we needed that slope and the point. The point is 1, 1 that we're going to use. So the slope would be rise 2, so a rise of 2 and a run of 2. So our slope is 1. That looks accurate to me. So then we have our point and our slope. So then we would do y minus 1, because it's when we put it in, it's opposite, equals 1 times x minus 1. Now, we don't need this 1 right here, so we really could write y minus 1 equals x minus 1. And we really don't even need the parentheses, and it would still mean the same thing. So the equation that we need is this one here. You can write it with the other point as well. It's just for consistency purposes, we'll always choose the right-hand point. All right, let's try this one. Again, y minus y1 equals m times x minus x1. So we need a slope, and we need that point, the x and y. So we're going to use the right-handed point, which is this one. So our slope, though, if I do rise over run, is 1, 2, 3, a rise of 3, and a run of 1. So our slope is 3. The point that's to the right is 2, 4. So when I write my equation, this would be y minus 4 equals 3 times x minus 2. So this equation would match that graph.